This video will discuss the processes by which we can charge things and give them an electrostatic charge. There's friction, conduction, and induction. We also need to know a couple of basic electrical properties of matter. One is a conductor is a material that allows the flow of electric charge easily through it. Things such as metals, right? Copper wires are a good example of that. The opposite of a conductor is an insulator, which prevents the flow of electric charges. So non-metals, things like plastic, wood, and glass are good insulators. So let's go ahead and look at the first method of electrostatic charging, friction. This is probably the most well-known method of electrostatic charging. If I give you a balloon and ask you to charge it, you'll probably rub it up against a piece of fabric or your hair in order to give it an electric charge to get that static electricity that you're used to. So basically what you're doing here is we're just simply rubbing objects together, and when you do that, the electrons essentially scrape off of one object on to the other. And so right now I have drawn both of these with some electrons and some protons, or some excess positive negatives. So we have 3 negatives and 3 positives on the balloon, giving us a neutral charge, and we have the same thing on the fabric, 3 negatives and 3 positives, and again that's making it neutral. So if we rub the balloon on the fabric, let's just use the example of the electrons themselves moving from the fabric onto the balloon in this case, which is pretty common occurrence with latex balloons. And so now you see that the electrons that we had on the fabric have now transferred over to the balloon. This gives us 3 extra negatives, so if we redo this little addition over here, we end up with a 3 negative, which is negative overall. And over here we have lost those 3 negatives over to the balloon, and that results in a 3 positive charge overall because there's no more negative, and that gives us a positive overall charge. So as you can see, when we scrape the balloon on the fabric, if it gains electrons, then it becomes negative because it has more negatives. But the fabric, having lost the negative charges, becomes positive because of the loss of the negatives, leaving more positives behind. The second method of electrostatic charging we want to talk about is contact, otherwise known as conduction. Probably the most common method of actual electrostatic charging. You may not have been familiar with it, but this is basically when 2 objects are simply in contact with each other. When they are, the electrons just move from one object to the other. Usually this works best when you have objects that are made up of different materials. So for example, let's say you're sitting in a chair. Your clothing is a different material usually than the chairs themselves. So just like we looked at before, the chair is going to have some charges in it, still neutral. You're going to have charges on your clothing, still neutral, but over time as you sit there, some of those electrons then from the chair maybe will move up into you. And so simply by being in contact with that chair, I've only drawn it here, but it happens on the contact along your back as well, and you're going to get that excess charge on you, so then when you stand up out of the chair, you now have an excess of electrons on your clothing that you didn't have before, and this leaves you with a negative charge. You now have an electrostatic charge that is negative due to the excess electrons. And the last method of charging we want to talk about is induction. And this is really what you observe whenever you notice something has an electrostatic charge. You ever feel that static clang, or you see things, changing and moving around a little bit when you bring something charged nearby. And so basically when a charged object comes near another object, usually the other object is neutral, the electric field around that charged object will cause the charges in the other object to become temporarily arranged. So remember we said that you had positive and negative charges would attract each other, and they attract each other because the electric field that the charge responds to reaches out beyond the object. So if you just bring the object nearby, the charged object nearby another object, it will cause a temporary rearranging of the charges in the second object. And that process and that result is what's known as polarization. So for example, if I take a balloon that has a negative charge built up on one side of it here, and say I bring it near the ceiling. Notice the ceiling has a neutral charge, same number of positives as it has negatives. If I then bring the balloon closer to it, you'll notice that the negative charges here are pushed away from the negative charges because they're repelled, and the positive charges are attracted towards or left behind near the surface here. So the negative charges are repelled and the positives attract. The result then is two separate areas. You have a negative area and a positive area. Those are the poles electrically, or in that polarization idea, but it's still neutral. And then the result is the balloon attracts to the ceiling, and it might even attract and stick to it. Hey, look, there's me. There's a balloon. I'm charging that by friction. Put it up there near the ceiling. The charges in the ceiling then got polarized just like the picture there, and I had enough charge that it actually allowed the balloon to stick to the ceiling and not fall down. Alright, this is also why the hairs on your arms stand up due to a nearby charged object. So if I bring the balloon near the hairs down here, the negatives will attract positives, so all the hairs will be positively charged, and negative charges will be pushed deeper down into your skin, so that you have a positive hairs and a negatively charged deeper in. And so the hairs then end up standing up because they're all the same charge, and since they're all the same charge, they keep trying to push away from each other, but they're attached to you so they can't go anywhere. This is also how you can pick up and move small neutral objects with a charged object. Say we have a bunch of little hole punches from your papers and stuff, and we bring that balloon near it, the same process is going to happen. Those positive and negative charges there that I've got labeled on those little circles, those little hole punches, are going to rearrange, and they're going to positive be attracted to the negative balloon, and the negative side will be pushed away. And as you can see in the video clip over here, that's exactly what's happening. But now notice if I turn the balloon around to the other side, there's really not much actual behavior response to the hole punches there. That's another interesting part of this whole thing. Kind of going back to the very beginning, the insulating material of the balloon does not allow the charge to move around. So when I rub that on my sweater, it charged that one side of the balloon, but the charges pretty much just stay right there, just like I've drawn in the pictures. But on the other side, there's really hardly any charge over there. You see one or two move a little bit, but nothing like what happens when you bring the other side of the balloon nearby. So those are your three methods of charging. You have friction, contact, and induction. Stay tuned, more to come later.